this video is all about the physics of softball.
Although softball is similar to baseball, it was originally created because of a football game. On Thanksgiving of 1887, Yale and Harvard's football teams were playing each other, and when Yale won, one of the supporters threw a boxing glove at a Harvard fan, who in return picked it up and hit it with a broom handle. Thus, softball was born. It was initially called names like mushball, pumpkin ball, or kitten ball, until receiving the term softball in 1926 by Walter Hackinson, who is shown in the center of this picture. Before it was considered a predominantly female sport, it was played indoors by baseball players to stay in shape during the off-season. In 1934, it gained official rules stating that it should be played with a 10 to 12-inch ball instead of a crumpled-up boxing ball. Now to look at the physics involved. Sir Isaac Newton created 3 laws of motion. The first states that an object in motion will stay in motion and an object at rest will stay at rest unless acted upon by an external force. This also means that the object moves in a constant direction unless acted upon by a force. In softball, the ball remains at rest until a force, the pitcher, pitches it towards the plate. If the force was never applied, the ball would remain at rest and would stay in its position. When the ball is pitched, it begins moving in a direction towards the catcher. If no external force is acted upon the softball, it would continue moving in that direction forever. However, there are external forces. When the batter swings and her bat collides with the ball, there is a massive force applied in the opposite direction of the softball's initial direction of movement. The opposite force is greater than the softball's, so the softball changes direction and will remain in motion until the force of gravity pushes it down and it comes into contact with the friction force from the ground, or is caught by a player's glove, which also has a force that causes the ball to cease motion and remain at rest, until, of course, the ball is thrown with a force that causes it to move in a new direction and the cycle begins again. The main forces involved in softball are forces exerted by the bat, gravity, air resistance, and friction. The traditional pitch for fast-pitch softball includes a large windmill-like windup, a long step forward, and a violent flick of the wrist to send the ball flying. The windmill windup increases the distance the ball travels, and in the equation V equals Fd, as the distance increases, the total velocity of the ball increases, which sends the ball towards the batter at a faster speed. When the pitcher rocks back and forth and snaps her wrists, she is adding force to the ball, which also increases the velocity of the ball, like the increasing distance does. When a ball is pitched, it is acted upon by the forces of the pitcher's arm, gravity, and air resistance. Gravity slowly pulls the ball downward, but the force of the pitcher's arm is greater than that of gravity and air resistance, so the ball continues to move toward the batter and the catcher. When a pitcher throws a rise ball, she uses her fingers to create a backspin on the ball. The backspin lowers the air pressure above the ball so that it has a rising effect. The ball does not actually rise, but because of a lowered amount of above pressure, there is less descent and drop. To throw a curveball, the pitcher must throw it with a sideways spin that decreases the air pressure on one side and causes it to curve. If an object can do work, then it creates energy. To create work, an object must have a force, F, cover some distance, d, and have an angle, theta. In this equation, those variables are shown. Because both the ball and the bat have a force applied and are covering some amount of distance, they both are doing work. And because the ball and the bat are most likely traveling directly at each other, the angle would be 0 and therefore cosine of 0 would equal 1, which does not affect the equation. By doing work, they are contributing to the amount of kinetic energy in the collision because the equation W net equals delta KE states the net amount of work is equal to the change in kinetic energy of the collision. The softball and the bat are both doing work and therefore are generating energy and are contributing that energy into the collision during a hit. The collision between the bat and the ball is inelastic because even though the bat and ball do not stick together after colliding, they still move in the same direction and there's a loss of kinetic energy. Inelastic collisions are defined as a collision where kinetic energy is not conserved due to forces such as friction. When the softball is hit, it usually comes off the bat with a different velocity than it is initially pitched, because the friction force between the bat and the ball that affects the amount of kinetic energy left in the ball after the collision. And also other parts of the energy are lost due to sound and heat given off during the collision.
Thanks for watching my video about the batting and pitching involved in softball, and I hope you enjoyed.